is some data around the price of an apartment to rent against the distance of the city centre. So it says that Xavier's conducted this study looking at the relationship between X and Y in the city of Melbourne. And we can see here the data that he's collected. So the distance away and then the price in millions of dollars. So the first part of the question says to write down the value of Spearman's rank correlation coefficient. Now, I would highlight here that this is only 1 mark. That tells us that we are not going to be ranking, working things out, and so on. If it's 1 mark, then it must be more obvious in terms of how to do it. We can also see here the wording, which is write down. It's not calculate, work out, it's just write down. So if we look at the data we've got here, you can see that it follows what we call a there we go. We can see that it just follows this same kind of level. It doesn't go up and then down, and it doesn't go back and forth this way. In which case, the Spearman's rank must be -1, because each of them are ranked highest, next highest, next highest, and so on, if we look at the X value, but it's also following the same thing if we look at the Y value. So we can see there that it is a negative gradient and it's a perfect gradient in terms of Spearman's rank. Then we have to find Pearson's product moment correlation. So for this one, we need to use our calculator. So we're going to go into data and we're going to type in the values that we've got. So 7, 8.4, 10.3, and I'm just typing all of this data in. And for the Y values or the Y coordinates, I have 2.61, 2.44, 2.03, 1.81, 1.45, and then the last one there is 1.18. So now we can go to statistics, calculations, and linear regression. Just make sure that if you've used your calculator for anything else, that you make sure the frequency is left blank, and then we can calculate it. And you can see here that the R value is negative 0.97919 and so on. So we always write our answer to 3 significant figures, so 0. And then we have 979. So we can see there that that is good, strong correlation, and it's negative correlation. So this flows nicely into the next part of the question, which says to circle the 2 things that make sense. So it is negative and it is strong. So we have negative, strong correlation. Now the next part of this question, because this is a paper 2 question, so they tend to kind of be a little bit longer and follow on from each other, is that the relationship between the variables can be modelled by a regression line. So we now need to find the value of that regression line, which we can actually see still on our calculator. So first of all, we're writing down the value of A, so it's AX plus B, AX plus B. I can check I've got the right one. So the value of A is here, and that is negative 0.0, and then 3 significant figures is 992. And then the value of B, so that's this one underneath here, is 3.19. And we can see there that we have the values of A and B. Then according to this model, we need to state in context whether the value, what the value of B represents. So B, if we think about our Y equals mx plus B, we know that B is the intersection with the y-axis. Okay, so it's where it crosses the y-axis. And if I go back to my scatter graph, where it crosses the y-axis, somewhere up here, or we can see it's 3.19, so it's actually above there, it's somewhere up here, is telling us where the distance from the city centre is equal to 0, okay? This would be 0 on the y-axis. So that means that B is telling me the value of is it a flat or an apartment? So an apartment. So the value of an apartment in the city centre. So it's 0 kilometers away. So it's right in the middle of the city centre. And then Xavier uses the regression line to find an estimate for the price of a typical apartment located 19.6. So this is where the X value is 19.6 kilometers. And I'm now going to substitute that into my line of regression. So my line of regression, we said, was y equals 0.0992. So this is just taking my two previous answers, times x, which is now 19.6, plus b, which is 3.19. And I can just use my calculator to work this out. So I have negative 0.0992 multiplied by 19.6, and I always use brackets, plus 3.19. So we can see that the price of an apartment there would be 1.25 to three significant figures. And then we need to see what the units are, and that's in millions of dollars. So millions of dollars. There we go. And then once we've done that, we can check whether the value seems about right. So 19.6 is somewhere around here. Does it make sense that it's 1.24? Yeah, I would say that does make sense if my line of regression is somewhere there. And then the question moves on, and it says to verify whether this relationship applies to a different direction from the city centre. Xavier considers two different locations, A and B, both an equal distance from the city centre, and takes a random sample of 7 apartments. So we now have two different samples of data, and we're conducting a t-test. So we have two samples of data, so it's a 2-sample t-test, and it's a 5% significance level, and we want to see whether or not they're the same. So write down the alternate hypothesis. We know that the null hypothesis is that the means are equal to each other. So the mean of A is equal to the mean of B, and we know that we can write the mean as this symbol here. So it says that they want to see if the mean apartment price in location A is different. We don't know whether it's bigger than, smaller than, or just different. And therefore, the alternate hypothesis, HA, is that the mean of A does not equal the mean of B. It's not equal to each other, rather than it being bigger or smaller. It just says is different. So the key word there is that is different. And then we need to find the p-value for the test. So we're now going to go back into statistics, and we're going to erase this data we had here. And we're now going to type in the data that we were given at the bottom here. So we had 1.21, 1.25, 1.31, 1.32, 1.58, 1.95, 2.13. And then for the second data in location B, we have 1.51, 1.58, 1.69, 2.61, 2.72, 2.81, 2.95. There we go. So with this data, we're going to go into statistics and tests, and we want a 2-sample t-test. Do not make the mistake of clicking the t-test because it will go wrong. So 2-sample t-test. We have the first sample in list 1, the second in list 2, and we want the alternate hypothesis to be not equal, so I'm just changing this. Make sure that your calculator is on pooled yes. It always has to be on pooled yes. And then we are going to calculate. And you can see here that the p-value that we were asked for is 0.022. So the p-value is 0.0224 to 3 significant figures. And then we need to state the conclusion of the test. So if I'm doing it to a 5% significance level, so you can see up here, 5%, then we're comparing the 5% to the p-value, which is approximately 2.24%. So since the p-value is too small, so it's less than the significance level, so the 2.24 is less than the 5% significance level. Therefore, that's a 5. We are rejecting the null hypothesis, which means that we will then accept the alternate hypothesis. Okay, so in terms of the marks of this question, the first one here is just 1 mark for seeing that it was -1. Oops, here we go. And the second one is 2 marks for rounding it correctly and then finding that answer. And then we have 1 mark for each of the correct circles. 1 mark here for A and 1 mark here for B. This is a communication mark, so it's whether you've correctly identified what that what the B value is. Then we have 2 marks, so 1 is for the method of using your line of best fit. So if you did get the answer wrong in the line of best fit in part C, then you would still get the method marks here and then the answer mark for working it out. And then the last part here is 1 mark for the hypothesis test, 2 marks including good rounding in the p-value, and then here we have an answer mark that comes with a reasoning mark. So you need to be able to reason and explain why the answer would be that.